Have you ever really stopped to wonder what the universe is truly made of? I mean, right down at the most fundamental level.
Yeah, beyond atoms, even beyond things like quarks.
Exactly. Based on the fascinating material we've looked at, today we're doing a deep dive into something pretty revolutionary. Quantum field theory. QFT. It's a framework that totally redefined how we think about reality. Honestly, it's kind of mind-blowing.
It really is.
There's this simple analogy, right, that the universe isn't empty, but it's filled with these invisible fields, like a calm ocean.
Right. That's a good starting point.
And when these fields get disturbed, get ripples. That's when we see particles. So our mission today is to give you a shortcut, a way to get informed about this incredible system, how particles and forces work at the tiniest scales. Okay, let's try and unpack this.
Well, what's really key here, I think, is that QFT isn't just one idea floating around. It's the fundamental theoretical framework in modern physics.
Right, foundational.
Yeah, it combines quantum mechanics, special relativity, and classical field theory. And it wasn't just mixing them together, it solved real problems that came up when you tried to describe tiny particles moving really, really fast.
Okay. Where the older theories didn't quite match up.
Exactly. The core idea, like you said, is particles aren't little balls bouncing around. They're actually excitations, quanta of these underlying fields that are everywhere, all through space and time, even in what we think of as empty space, a vacuum.
So an electron is what? A ripple in the electron field?
Precisely. And a photon, a particle of light, that's a ripple in the electromagnetic field. Even the famous Higgs boson, that's just an excitation, a ripple in the Higgs field.
Okay, so fields everywhere, particles are just disturbances, bumps in the field. That's a huge shift from thinking about tiny objects.
It absolutely is.
But, okay, if they're just ripples, how do they appear or disappear? And what does this whole field idea mean for how physicists even think about, like, empty space?
Yeah, that's crucial. QFT brings in these mathematical tools called creation and annihilation operators.
Okay.
Basically, these operators allow the fields to change dynamically. They make the ripples, the particles pop into existence or vanish, all while perfectly obeying the universe's speed limit, the speed of light from special relativity.
Wow, so the math actually describes particles popping in and out of existence.
It does. It was built really to explain things scientists couldn't even directly see yet, like predicting the Higgs before it was found. And this ties into how forces work, too.
Ah, right. You mentioned forces.
Yeah, forces like electromagnetism, or the strong force holding atomic nuclei together. They come from interactions between these fields. And those interactions are carried or mediated by temporary particles called virtual particles.
Virtual particles, like temporary ripples.
Kind of. Think of virtual photons carrying the electromagnetic force between two electrons. They're like short-lived messengers transmitting the interaction through the field. It's the foundation of the standard model of particle physics, really.
Okay, let's bring this back a bit. So, what does this all mean for us trying to understand the universe?
Well, it fundamentally changes the picture.
Yeah, it redefines particles, not as little things, but as these vibrant excitations in fields that fill everything, like the sources really emphasize.
Exactly.
It sounds incredibly abstract, maybe, but QFT has had a huge impact, right, in the real world.
Oh, absolutely. It's the bedrock of modern particle physics. Think about experiments like the Large Hadron Collider.
They rely on QFT predictions.
Completely. And it directly led to discoveries like the Higgs boson, confirming that Higgs field exists. It's incredibly powerful for predicting how particles behave, especially when they have enormous amounts of energy.
So it's tested, it works.
It's one of the most rigorously tested theories in physics. What's really fascinating here, though, is how profoundly this changes our view of matter and energy.
How so?
Well, if everything we see and interact with light, chairs, us, if it's all fundamentally just ripples in these underlying fields, it really makes you ask, what does that imply about the ultimate nature of reality?
That's a deep question.
It is. It highlights this ongoing quest in physics, doesn't it? To see the universe not just as a collection of objects, but as this incredibly complex, interconnected, vibrating tapestry. Maybe the next time you look at something solid, you might just ponder the invisible ripples making it up. It definitely gives you something to think about.